Okay, so let's just do an overview of the application problems that you have assigned for Module 3. So as we said, practice problems, we just got done doing those in the sample problems that we just looked at. So now you're ready to hand these in for credit for those. If you need to go back to the videos, I'll have those posted later this evening. But now you can do the application problems, which I like to say is your homework, right? So these are all going to be in the section starting on page 47. We're going to do 32, 34, 36, 38, and 44. You're going to notice here I have the page number identified, and I also have just the final answers here. So this is a good way that you can check if you're on the right track with the work you're doing, if you get the right final answer, okay? So I'm going to go underneath our camera. The first problem that we have here is problem 232. It says we have two cables are tied together at C. They're loaded as shown. Knowing that alpha down here is 30 degrees, determine the tension in cable AC and cable BC. Now, these need to be done using the rectangular component method only. All right, just the way that we did these last three sample problems. So as you can see here, C would be the center of your X and Y axis, okay? And then you would have 6 kilonewtons going to the right along the x-axis, and then going up and to the left would be your force A, if you wanted to call it that, along that angle or along that cable. And then you're going to have one going down and to the left to point B, and that's going to be along that cable. So you want to find what is the tension in cable AC and in AB. So this is very similar to the first problem that we did. Okay. Actually, each one of them, honestly, very similar. So rectangular component method, finding the tension in each one of those cables. So drawing your diagram, doing the components, summing your forces in the X and Y equals 0, and then solving for any unknowns. Brooke. No, it's just the line that's along there. No. Yeah, if this is pulling away in this direction, these have to go up and to the left. So the line is only a designation of the line. It's not a designation of the direction of the arrow. Yeah, good question. Others. Okay. Then your next one is going to be 234. 234 is right here, okay? Here we have two cables are tied together at point C. They're loaded as shown. Determine the tension in AC and in cable BC. So coming from point C, you're going to have the your arrowhead going down for the weight of this block. Now, they're giving you the mass of that block. So your weight is going to be equal to mass times gravity. So don't forget to do that, okay? Because you're not going to solve this in kilograms. You have to have it in newtons. And then each one of the forces is going to go up and away and down and away from point C at the center. And then you're given your angles that you see there, and then your X and Y axis will go right through the center there. Okay. So that's the first two. Again, rectangular component method only. All right, for all of these problems. The next one you have is going to be 36. 36 is at the top here. Here you have two cables come together at point C, right in the middle here, loaded as shown. Knowing that P is 500 newtons, so it's going down and to the left, and that alpha is 60 degrees, right here. Determine the tension in the cable, so pulling up away from C towards B, and up from C pointing towards A. Whenever they say tension in the cable, that means that it's like pulling, not pushing, okay, on the point. Again, rectangular component method for that very same process that we've been using. And again, using your equations of equilibrium. This is not resultants anymore. So number 38, that's looking at this problem or this illustration just above, says we have forces P and Q. So P and Q are applied as shown on the bracket. Knowing that the connection is in equilibrium, some of the forces in the X equals 0, some of the forces in the Y equals 0, and that P is equal to 600 and Q is equal to 800, determine the tensions in rods A and B, and they're showing you that. Now, they're extending their line of action so that they share that same common point. So you're going to simulate this just like we did before on all of our problems, X and Y axis, and they're all going to come from that origin with their common point, concurrent force system. So A and B, the tensions in A and B are what you're trying to find. Your next one is going to be 44. And it says for the cables in problem 236, problem 236. Up here. So we did 236, okay? It says, it is known that the maximum allowable tension is 600 newtons in cable AC, okay? And 750 in BC. So you're going to put, I'm sorry, I forgot the numbers, 600 and 750 along AC and CB. And then it says determine the maximum force P that you can hold with that. Okay? And the corresponding value of alpha, right? So here you're going to have known forces along the cables, and then P is going to be unknown. So kind of working that problem, if you would, backwards from what it was originally given. All right. And then, is that the last one? Just double check. I think so. It must be. Yep. And 44 is the last one. All right. So rectangular component method, practicing those equations of equilibrium, using kind of that very same process that we did as we went through. And you should be ready for these 5 problems. All right. So that's all that I have as far as content tonight. The rest of the evening, I'm going to give you a chance to, stick around, work on homework, and I'll be here to answer any questions that you might have. I'm going to stop